Right, in this video, we're going to learn about what a one-way function is. So before we get started, let's take a look at a two-way function. And I've got something real simple that we're all familiar with. This is just an equation, like a formula or an equation like you might see in an algebra class. And if we look at this equation, right, this x variable here, well, this is like the input of the function. That's the input. And then the y would be the output of the function. So there's two kinds of problems we could solve. One of them, if I said if the input is 12, what would the output be? Well, that's easy. You take the equation, you plug in 12, and we know that the output is 32. And if I were to reverse the problem, like if I could have asked this a different way, and I could have said, well, suppose the output is 32, what would the input be? And so you'd write your equation like this. You'd say 32 equals 2x plus 8 and subtract. And so after you go through all the algebraic steps, right, you know the input is 12. And so this is true. So this is a two-way function because if I give you the input, you can compute the output real easily. And if I give you the output, you could also just reverse the process and determine the input real easily. And this is basically like, in most of the more math courses that you've taken, pretty much any, function that has just the standard operators, plus, minus, times, times and division, exponents, all of the, any equation that just involves these basic operations is generally going to be a two-way function. It's easy to reverse the process. All right. So now let's look at another kind of arithmetic. And if you haven't studied computer science, maybe you haven't heard of modular arithmetic before. So modular arithmetic, I'll write a problem like this, and I'm not using an operator symbol, I'm just going to use the word. So if I said 37 mod 5, the answer to this is going to be 2. And so, how did we get this value? Well, you have to think like a little kid, right? So when you were a little kid and you did division, if I wanted to do 37 divided by 5, I would say 5 goes into 37, and then it goes into it 7 times, and I multiply, and it's 35, and I get a 2. And so, let's think about like what you did. So somewhere, I don't know, maybe 5th grade or so, you learned about decimals. You would have probably wanted to write your answer as like 7.4. Okay, but before you knew about decimals, you didn't do that. You might have written your answer as 7 2/5, and that's an acceptable answer. But think to when you very first learned long division, you didn't do that either. You just wrote the remainder of 2, and that's what the modulus does. So it gives you the remainder after the division. So when you have an equation, if I give you a number modulo another number, it's really easy. We have an algorithm that a 3rd grader can do to get the modulus. But what if I ask the question a little bit differently? And so this time I'm going to say, some number mod 5 is equal to 2. Now we have a different problem here. Okay, so this is the output. What is the input? What was the input? And it's like, well, it could be lots of things. So, like we saw, it could have been 37, but it could have been 7. would have been a good answer because 7 divided by 5 has a remainder of 2. Could have been 12. 12 divided by 5, 2 left over. Could have been 17, could have been 22, and so on. So what we have is an infinite number of solutions to this. So it is, if I said I did some number mod 5 and got 2 and said what was the number I started with, the only way for you to know is just to take guess after guess after guess until I finally say that, yeah, that was actually the input I used, right? So this is a problem that is easy to do one way, and it's hard to do the other way. All right, so let's look at another example of something that is easy in one direction and hard in another. So here I've got a couple of prime numbers, and we know what a prime number is. A prime number is a number that is divisible by 1 in itself. And so now I'm taking two prime numbers and I'm going to multiply them together. So we've got an algorithm for this. Okay, 7, carry the 2, and 3, and that's 5, and then 0, and then 1, 9, and it's 247. So taking two numbers and multiplying them together, right, is a relatively easy process. And this result we get, this is called a semiprime number. Right, so easy. And even with big numbers, this would be easy for a person to do with really, really big numbers. As long as you have a calculator, it's still very, very easy and nearly instantaneous. All right. But let's ask the question the other direction. Okay, so what are the factors of? And so 377 is a semi-prime number. And let's say I wanted to know the factors of it. We're kind of in a bad situation here. It's like we really don't know. Like it could be, so it really comes down to like kind of a guess and check process. So I can say 377 and, well, it's not going to divide by 2, but because it doesn't end with it's not even. But I'll divide it by 3, and it's like, nope, that doesn't go even. I'll do 377 divided by 5, 75.4, so nope. 377 divided by 7. Okay, and I'm not going to check 9 because I know it's not divisible by 3. So I'll do 377 divided by 11, and it still doesn't come out even. And so 377 divided by 13, and it's 29. So now I know that this is 13 times 29. So that was I guess it wasn't too terribly difficult to do using a calculator, but one of the things you can see is, factoring a number ultimately, it is going to come down to some guess and check. Okay, some kind of systematic guessing and checking. And even a computer, if it's going to factor a number, has to do some systematic guessing and checking. Excuse me. All right. So let's make the problem a little bit more difficult. 3, 5, 4, 1, 7, 8, 9, 8, 3, 1. All right. So let's take a number like this. This is also a semi-prime number. And this is, so if we wanted to figure out the two factors of this, right, I could sit down with a calculator and just start typing that in. Divided by 3, no. Divided by 5, no. Divided by 7, no. And I suppose eventually I'll get there. But rather than do it, I'll just go ahead and tell you, right, the factors of this were 49,003 and 72,277. All right. So I don't think that I was going to get there anytime soon. And these are both prime numbers. Okay. See, these are also prime numbers. So, but when I found these two, when I was figuring out this number, right, I took these two numbers, punched them in the calculator, and it was, again, it's easy to compute the product of two prime numbers, but it is hard to find the factor of two prime numbers. And a computer could do this basically instantly. A computer could do this reasonably quickly. But if we made a semi-prime number that was the product of two prime numbers that were perhaps hundreds of digits long each, we can turn this factoring problem into something that, all right, even the most powerful computers in the world would take perhaps billions of years to solve. So, right, so this is another example of a one-way function. All right, so let's look at a definition of a one-way function. And a one-way function is a function that is easy to compute for every input, but hard to determine the input when given the output. And so easy one way, hard the other way. And easy and hard are kind of ambiguous words to define. Easy just generally means a computer can calculate it real quick, and hard is somewhat dependent on the processing power that the computer has. But we are at the point, we do have the technology to, or the, I guess, mathematical knowledge more than the technology to come up with problems that even very, very fast computers take a long time to do. So anyway, if there's something to take away from this, it's that modulus and factoring semi-primes are just two examples of one-way functions. And it turns out that these two procedures are the basis for encryption and all secure communication that we conduct on the internet today. So, in some other videos, we'll look a little bit more specifically how they're used. All right, but at least hopefully, you see now, if you didn't see before, that there are, not all functions are just as easily to do one way as they are the other direction. All right, thanks for watching.